Welcome friends to my YouTube channel. Now on yesterday's lecture I have told about the various elastic constants and their interrelations. Now in today's lecture I shall going to prove those relations. Okay, the first relation. So the first relation between different elastic constants that I write is y this is equals to 3k into 1 minus 2 sigma, where y is the Young's modulus, k is the Mach modulus, and sigma is the Poisson's ratio. So how we can verify it? So just imagine a cube. Okay, just imagine a cube whose sides are of length unity. That means we have to consider a cube whose length of the sides are unity. Okay, and the sides of the cubes coincides with the three coordinate axes. Okay, sides of the cubes coincides with the three coordinate axes. So we take a unit cube, we take a unit cube, sides of the cube coincides with three axes. Okay, so we apply a force, that is force per unit area P, along that acts along each face of the cube outward. Okay, that is we apply the force in such a way that each force acts outside. Okay, that means we apply a tangential force P per unit area such that this force acts outward. Okay, so tangential force per unit area, that we assume say P. Okay, now here we have to find out what will be the effect of this force on the cube, that means on the three sides of the cube. Okay, so at first take the x-axis. Okay, so at first take the x-axis. Now clearly it is seen that along x-axis this force acts along outward. Okay, that means there is a elongation. Okay, along x-axis. So due to the force acting along x-axis, that is this force, the cube will be elongated along x-axis. Okay, similarly due to this force that acts in the x-axis, the cube will be contracted along y and z axis. That means under the application of the force along x-axis, the cube will be elongated along x-axis and contracted along y and z axis. Okay, so cube will be elongated along x-axis and contracted along y and z axis. So the contraction along y and z axis is lateral contraction. Okay, now we know that Young's modulus is similarly is equal to longitudinal stress, that means P by longitudinal strain, say small e. So from which we can write E, this is equals to P by Y. So this amount of elongation takes place along x-axis. Okay, this amount of elongation takes place along x-axis due to the force acting along x-axis. Okay, now let us see how much amount of contraction takes place along y and z axis. That we know from the definition of sigma, that is Poisson's ratio. That is sigma means lateral strain by longitudinal strain. Okay, so what will be the lateral strain along y and z axis? তাহলে lateral strain along y and z axis is similar, simply sigma multiplied by extension along x axis, that is p by y. Okay, so this amount of contraction takes place along y and z axis due to the application of the force per unit area p along x axis. So that means, okay, so if we apply a force p by y, there is a elongation along x axis p by y. So due to this force, the contraction will along y and z axis is this. Okay, this is the effect of x axis along x axis. So similarly, if we apply the same forces acting along y axis, and due to that force, p by y amount of extension takes place along y axis, and minus sigma p by y amount of contraction takes place along x and z axis. So if we take y axis, okay, so due to the application of this force, p by y amount of elongation along y axis, and sigma p by y, this is the amount of contraction along x and z axis. Okay, and similarly, if we consider z axis, then due to this force, p by y amount of elongation takes place along z axis, and this amount of contraction takes place along x and y axis. Okay, so this is the net result of the forces acting along three different axes. Okay, so how much amount of elongation along three axes? Okay, so elongation along three axis, that is simply, for x axis this is simply p by y minus sigma p by y minus sigma p by y, and similarly for y and z axis the expression will be same, because minus sigma here, minus sigma p by y is twice and p by y is one times, and here also. So along three axes the elongation will be same. Okay, now here I give the minus sign, that is minus sigma p by y, due to the fact that contraction takes place. Here we use positive sign for elongation and negative sign for contraction. Okay, so this is the net elongation along three sides. Okay, fine. So we imagine the cube as a unit cube. That means initial volume is what? The initial volume of the cube is what? We imagine the sides 1, that means initial volume is 1. And what would be the final length of the sides of the cube? Okay, the final length of the sides of the cube are what? The initially there is length 1, and this amount of elongation takes place. So 1 plus p by y into 1 minus 2 sigma. This is the final length of the sides. Okay, so what would be the final volume of the cube? Final volume of the cube, simply this cube, 1 plus p by y 1 minus 2 sigma. Okay, initial volume is 1 because we imagine the sides to be of unit length. So what would be the final length? Initial plus increment, and how much amount of elongation takes place? That is p by y into this. So this is the final length of the cube. So this is the final volume, and this term is very small. Okay, that means here we can ignore the high order terms, that is we use the square and cube, we ignore the square and cube of this term since this is very small. Okay, a cube plus 3a square b, up to this we take, and we ignore the terms like square and cube terms. Okay, b square b cube, that terms we ignore since this is very small. Okay, so final volume is this 1 plus 3p by y into 1 minus 2 sigma, and initial volume is 1. So what will be the change in volume? So what will be the change in volume? So change in volume is simply this minus this, 1 plus 3p by y, 1 minus 2 sigma minus 1. So this means 3p by y into 1 minus 2 sigma. Now what will be the volume strain? Volume strain is what? That is simply change in volume by original volume. So this is change in volume, and original volume of the cube is 1. So this by 1, that means this. This is the volume strain. And what is the volume stress? Initially we apply a force per unit area P. That means this is the volume stress term. Okay. That means we apply a force per unit area P, and the reaction force will also be same P. Okay, so if we take just the magnitude, so volume stress will be P. Okay, so what will be my Bach modulus? Simply my Bach modulus K is volume stress P by volume strain, that is 3p by y into 1 minus 2 sigma. Okay, so pp cancels, so k, this equals to y by 3 into 1 minus 2 sigma. So simply this is y, this is equals to 3k into 1 minus 2 sigma. Okay, so this is the first relation, that how this relation comes. We consider a unit cube and then apply a tensile force per unit area, and we see the effect of this force along 3 axes. Okay, and by simple algebraic treatment we arrive at the first formula. Okay, so in my next class I will discuss how the other formulas can be obtained. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos. Okay, so and if you have any query, then just write it in comment section. Okay, thank you.